Welcome to the fifth section of our course. In this section, we'll be creating non-blocking reactive flows with Spring Reactor. Firstly, we'll be creating non-blocking data access layer using Flux. Then we'll be adding non-blocking GET REST API at top of it. Third video will be about creating reactive write path. Once we will have that, we'll be testing the reactive approach for writing data and reading it back again. So we'll test it from the end-to-end perspective. This is the first video in which we shall be creating non-blocking data access layer using Flux. So firstly, we'll be wrapping blocking repository using Flux, then we'll be creating repository that works in a reactive way, and finally we'll be creating reactive method for retrieving our data. So let's go to the code. So here is our reactive salary service. We will be using salary repository that we created in one of the previous sections. So let's take a look at the salary repository. So salary repository is a simple interface that just extends CRUD repository, and it takes a salary and long. Long is an ID and salary is just a salary entity class. So if you will take a look at it, it will have an entity annotation, so ID and some other fields. Once we have that, we will implement two methods. First one is find by user ID. We are passing user ID as a parameter here to our query, and then there is a find by from account. So another API method that is finding by this time for the account from. But at this point, salary repository could be injected anywhere, but it is not reactive. It will work in a blocking way. So how to make it reactive? For example, we can wrap it in our Flux API. So let's take a look firstly at the method that is retrieving our data by the salary. So we'll have a getSalary method that is doing exactly that. So let's analyze the logic. So firstly, we have blocking call that is called find by user ID. We are passing our user ID parameter to this method, and at this time it will block our thread. To execute it in an async way in a different thread, we can wrap it in the mono_just. So it will execute that in an asynchronous way, but it needs to be wrapped once again, but this time in a mono_defer. Defer is an asynchronous operation, and it takes lambda as a parameter. This is important to note here. You can see that lambda is passed here, not the direct invocation. If you will execute direct invocation here, it will be executed and return value will be used. That's why compile error is created to prevent those errors. So we want to execute it in an asynchronous way. That's why we are passing lambda. That lambda will be executed sometime in future, and it doesn't block our execution thread. So getSalary will return immediately. What's important as well in using Flux, we can chain those operations in an asynchronous way, and they will be executed in the future, but we can create the graph of execution right now. So first we are subscribing on Elastic Scheduler. So it means that this action that is executed in this asynchronous callback will be executed on this thread pool. So here there is an Elastic thread pool that is just creating thread pool with some multiple threads that will be used. So we are subscribing on that, and this asynchronous action will be executed on this thread pool. You can pass any thread pool that you want here. Once you have that, you can map your result to your DTO object. So this is important. So we are retrieving P. In this example, P will be our salary. So it will be unwrapped and we will get P. But as you remember, find by user ID is returning list of salaries. So we need to stream everything, and we are mapping every salary that is inside of it, and we are creating salary DTO, mapping user ID, account from account to amount, and finally we are collecting everything. But once again, this is executed in an asynchronous way. So only when this action, first one, the provider, will finish, the map action will be executed, not later.